So this problem was from the 2025 Berkeley Mini Math Tournament Individual Round, problem 20. So basically it was the last problem. It was the last question on the 2025 Berkeley Mini Math Tournament Individual Round. So yeah. So let's read the problem. So basically, it says that there exists increasing arithmetic sequences of real number a, b, c, and p, q, r, having the properties that q is a positive integer greater than 1 and that the equation x cubed minus a x squared minus c equals 0 has solutions p, q, and r. Over all such pairs of increasing arithmetic sequences, what is the least possible value of p plus q plus r? So I decided to talk about this problem because I feel like this was a really good algebra problem because it actually included many it actually included a lot of very important and interesting algebra concepts that actually come out a lot in algebra problems and contests. So let's go over it. So basically, first we have to note down some things about the problem. So we have A, B, C, and P, Q, R, and these are both arithmetic sequences. I don't know, you've probably seen many problems where they say that certain numbers form an arithmetic sequence, but instead of moving on, you should actually think about it, because in this problem, the fact that they're arithmetic sequences is actually very important to this problem, because through the properties they have, it's actually part of the reason we can solve it. So let's explore the arithmetic sequence properties. So basically, remember that an arithmetic sequence is just a sequence where each term, between each term, there's a common difference. Therefore, we can write so for PQR, let's just call the common difference n, I guess. Oh yeah, remember P, Q, and R are the roots of this polynomial. So let's say P equals Q minus n. But yeah, as I said, n is a common difference. So R is Q plus n. And also note that another really important and powerful property of arithmetic sequences is that when you sum the first and last term of the arithmetic sequence, so in this case it's P plus R, their sum is two times their average term, so in this case it's just 2q. And this also means that A plus C equals 2. This also means that A plus C equals 2b. And this is actually going to be very important for this problem. So basically, using this, let's continue the problem. So after that, it also says that PQR is the roots for the polynomial x cubed minus 8x squared plus bx minus c equals 0. So yeah, and because there are roots, this triggers us to use the Vieta's formula. This is one of the most important formulas in polynomials for competition math. So if you don't know these, then you should really learn them, or you should just continue watching my video. So yeah. So the Vieta's formulas gives that in a polynomial, just like this one here, the sum of roots in that polynomial can be written as negative a sub 1 n minus 1 over a sub n. So in this case, it just a sub n minus 1 is negative a, and a sub n is 1. Oh yeah, it's just the coefficients, by the way. And since negative, that's just a for this in this case. And product is just equal to negative 1 to the power of n times a 0 over a n. And on another important one that we're gonna use in this problem specifically, this is also important, but it doesn't come up as much as these two. These two are really important. Is the sum of roots 2 at a time. So like, for example, if the roots of a specific polynomial, like 1, 2, 3, 4, then 2 at a time would just be 1 times 2 plus 1 times 3 plus 1 times 4 plus 2 times 3 plus dot 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 plus 3 times 4. So that's what the third formula would be about. So let me clear that. So basically, with that we get that the sum of the roots 2 at a time would be it's some wait sum of root 2 at a time. This is a sub n minus 2 over a n. So now we applied these Vieta's formulas to this problem. So our polynomial here is x cubed minus ax squared plus bx minus c equals 0. So applying this, we get the sum of roots, which is negative an minus 1 over an. It's actually just a. And then now, instead of just saying that a is the sum of roots, let's see the representation of a we made using the arithmetic sequence rules, which we did here. So because of this, we know that a is just 3q, because q minus n plus q plus n plus q is 3q. So a equals 3q. And then we also have the product of roots. Well, here negative 1 to the power of n, that's negative 1 cubed. Negative 1 cubed is negative 1. And a0 is negative c, a sub n is 1. So it's just negative 1 times negative c, which is c. C is the product of roots. So C, the product of roots, it can also be written as q minus n times q plus n times q. And notice that here the q minus n times q plus n, that's just the difference of squares. So it's q squared minus n squared times q, which is q cubed minus q n squared. So yeah. So basically now we can do b. So what is b? B is the sum of roots 2 at a time. Yeah, b is the sum of the roots 2 at a time, because that's just b over 1, which is b. And then remember, we get that B was equal to A plus C. So now we can represent sorry. I meant, remember we B, which is the product of roots 2 at a time, so we can just write the product of roots 2 at a time. We get q squared minus nq plus q squared minus n squared plus q squared plus nq, and summing these up we get 3q squared minus n squared. So now we can use this fact to make another equation. A plus C equals B. This means that 3q plus 3q is A, and then plus C. C is this. 3q plus q cubed minus qn squared equals B, which is, I mean 2B, which is 6q squared minus 2n squared. So now we can rearrange this equation a bit. In case you're wondering, the reason I would want to rearrange is to make it easier to factor. So to do that, we can write it like this: q cubed minus 6q squared minus 3q equals qn squared minus 2n squared. And here it's easy to factor because on this side we can factor out n squared, on this side we can factor out q. That's q times q squared minus 6q minus 3 equals n squared times, n squared times q minus 2. Let's isolate n squared. Q times q squared minus 6q minus 3 over q minus 2 equals n squared. So here now we're just dealing with mostly just q's and like one n squared. But remember that n is just a common difference in the arithmetic sequence p, q, r. So since we don't really know the values of p, q, and r, we can't really find the value of n since it's just a common difference between terms, and nor can we find the value of n squared. But we still want to somehow get this n squared term out of our equation using a number so that we can have a one variable equation and solve it easily. So how can we do that? Well, we can do that by, since we don't know what the real value of n is, we can maybe somehow just think about what properties we know about n and maybe make like an inequality or something like that for n, I guess. For n squared. So basically, notice that since p is not equal to q and is not equal to r, what does n is the difference between them? What does this mean? This just means that n has to be greater than not greater than. N just has to be not equal to 0. And as long as n is not being equal to 0, this means that n squared will be greater than 0 because even if n was on the negative side, its square will still be greater than 0. So this just means that we can write this as q minus q squared minus 6q minus 3 over q minus 2 is greater than 0. And then we can multiply both sides by q minus 2 to get rid of the denominators. So q times q squared minus 6q minus 3 greater than 0. Now divide both sides by q, so q squared minus 6q minus 3 is greater than 0. Now let's complete the square. So completing the square gives q minus 3 squared is greater than 6. So now what? Now that we already got here, now all we have to do is just find out what the question's actually asking for. It's asking for the least, It's asking for the least possible value of p plus q plus r. Remember that p, since we got this expression over here, this means that p plus q plus r is just 3q. And so we're basically just tasked to find the minimum of 3q. And this just means that we just have to find the minimum of q, because once we find that, we just multiply by 3 to get our final answer. So how do we find the minimum of q? Well, just use this expression over here. So remember that from the problem, it says that q is a positive integer. So this means that we have, so q minus 3 is just equal to the greatest positive integer whose square is greater than or equal to 6. This is 3. This is because 3 squared equals 9, which is greater than 6, while the lower positive integer, which is 2 squared is equal to 4, which is less than 6. So q minus 3 has to equal 3. This means that q equals 6. Since q equals 6, this whole time I wrote equal. The truth is that's not equal, just greater than or equal to. I just wrote equal to because that's what we're trying to find. Wait, no, not 6. 3 plus 6. So this just means that our final answer, we just multiply by this by 3. So our final answer will just be 18. So yeah. So that we got our final answer of 18. So as I said, this was the hardest problem on the 2025 individual Berkeley Mini Math Tournament individual problems. So yeah. So and here we just solved it, and the final answer is 18. And basically, in conclusion, in this problem we learned how to apply arithmetic sequence properties, Vieta's formulas, and just factoring and completing the square, and many algebraic expressions in general. And almost all my YouTube videos demonstrate this, so make sure to like and subscribe to see more of those. So please like, subscribe, turn on notifications, and drop a comment in this for this video. Thanks.